2 pi over 3. And this is 4 secant squared. And remember, secant is not in the calculator. You have to write it as 1 over cosine. So 1 divided by cosine x close square and dx. Be very careful. If you don't have enough parentheses, it may not give you what you're looking for. So these parentheses are for x. These are for the power, and these for the function. So when I click enter, I don't know what I'm getting because it's going to be some gibberish. But I will have 4 the square root of 3 minus the square root of 3 over 3. Be very careful not to put it under the square root. Take it outside, divide by 3, and close. When I click enter, if I don't get this gibberish, then I know, oops, assuming that I entered the function correctly here. So I don't want you to use this feature if you don't enter it correctly and you get something wrong and you spend half an hour on this to fix it. Because if you don't enter it correctly, you're not going to get the same thing. Okay, let's see. Where's my book? Let's see if we are interested in anything else from here. Yeah, maybe 41. Before that, any questions on 37, please? Okay, 37. No, 40. I'm sorry, 41. The integral from 1 to 2, x over 2 minus 2 over x, and dx. Let's see, is there anything else that interests you as of now from here?
Yeah, do you think we could do 43 as well?
Yes, of course, 43. Let me copy it. Where is it? Okay, the integral from -2 to 2 from hyperbolic sine plus hyperbolic cosine dx. Perfect. Anything else? Okay. So let's look at these two. So obviously for x over 2, I have 1/2, and this is x squared over 2. Minus, this is 2, and natural log of the absolute value of x from 1 to 2. I skipped, sorry about that. So this function is linear. It's defined everywhere. This function is rational, and it's not defined at 0, but 0 is not here. So then 1/2 goes in front, and x squared over 2 prime is x, and minus 2 natural log of the absolute value from 1 to 2. So now I will plug in 2. So I have 4 over 2, which is 2, times 1/2, which is 1, minus 2 natural log 2, minus, don't forget to put parentheses. And when I plug in 1, I have 1/4. When I plug in 1, I get 0. So minus 2 times 0. So the final simplified form will be 1 minus 1/4, which is 3/4, minus 2 natural log 2. Again, if you want to check with the calculator, you have to approximate this and approximate that. This is the exact. Whatever the calculator gives us, it will be an approximation. Now for the other one, 43. The integral from -2 to 2 from hyperbolic sine plus hyperbolic cosine dx. Okay. Which function prime is hyperbolic sine? Well, this is hyperbolic cosine, not minus. Plus, which function prime is sine, hyperbolic sine? I meant hyperbolic cosine, hyperbolic sine, from -2 to 2. Now the thing here is that I don't know a way of determining this with the graphing calculator unless we change each into what they're equal to. So hyperbolic sine is e to the x minus e to negative x over 2, and hyperbolic cosine is the same thing but with plus. So I will plug in 2 in hyperbolic cosine, and how we'll plug, and then in here, and then subtract when I plug in -2. I don't even know if we can plug this in the graphing calculator if the function exists, and it should, but maybe they say no, we don't put that in because you will have to evaluate this. So I can write it as hyperbolic cosine 2 plus hyperbolic sine 2 minus hyperbolic cosine -2 plus hyperbolic sine of -2, and then calculate that. Is this what confused you or something? Is this okay?
Yes, thank you.
Okay, perfect. So now I would like to continue with something called properties. Now we know what the definite integral is, and now we have properties of the definite integral. Properties of the definite integral. Okay. Number one, the integral from a to a from f of x dx. What do you think this equals to?
0.
Yes, absolutely 0, because there is no interval. What is the base? The base does not have a width. So dx does not have a width and to determine f of x. Indeed. 2. The integral from a to b from f of x dx happens to be the opposite of the integral from b to a from f of x dx. So remember, if you want to change the limits of integration, swap them, not change. If you want to swap them, all you have to do is put a minus in front. If there is a minus in front, you can swap the limits of integration and turn it into a positive. Okay, number 3.
So sorry, but that has a negative sign and the letters are swapped
Yes.
on the right-hand side?
Yes, so let me give an example. The integral from 2 to 3 from f of x dx is the opposite of the integral from 3 to 2 from f of x dx. Is that okay?
Yeah, okay.
Okay, now I would like to talk about odd functions. Another property. On a symmetric interval. Odd functions on a symmetric interval. That's property 3. This was an example here. Okay, I'm going to go to the next page. So here's what I mean by an odd function on a symmetric interval. Here's an odd function. It's x cubed. On the interval -a to a. What do you think the integral from -a to a for this function that is odd, dx will equal to? Like from the integral from -3 to 3 or -5 to 5, what do you think this will equal to? As long as it's odd plus symmetric interval. Both conditions have to be fulfilled. What do you think? Will the answer be?
2 times the...
Careful. This is a negative area, and this is a positive area, and they are equal.
0.
Excellent. So every time we look at a symmetric interval, otherwise I would not check if the function is odd or even, but every time you're giving me a symmetric interval, I will immediately check whether this piece is odd or even. If it's odd, I'll write the answer 0 and move on. If it's even, we're going to talk about it in a moment. Perfect. So the property number 4, even function plus symmetric interval. Okay, let's take a look at this. Here's an even function like x squared. X squared is an even function, symmetric with respect to the y-axis. And I'm going to say negative a to a. It has to be a symmetric interval. So then the integral from negative a to a from f of x dx will equal, and now you can say that.
I was going to say 2 times 0 to a.
Yes. Perfect, indeed. 2 times the integral from 0 to a from f of x dx. So there is always easier to calculate an integral starting with 0 than an integral starting with negative a or negative 5. Since the areas are both positive and equal, I would just put 2 in front because there are 2 pieces, and I will only calculate this area and simply multiply by 2 at the end. Awesome. Number 5. If the function is a positive function on the interval a comma b, what do you think for sure the integral from a to b from f of x dx must be if the function is positive on this interval? What do you think about the integral, the area under the graph between a and b? What type of number must it be?
Positive?
Yes. Yes. Perfect. Stay with me because the next one is related. Next property of the definite integrals is related here. Number 6. And page. Good. If I have this situation on the a comma b, what does this mean? Okay. It means on the interval a comma b, function f is here, and function g is here. What would you think about the areas? This is the area under G, and this is the area under F. The area between A and B from f of x dx, and the area between A and B from g of x dx. What would the relationship between these two be? Which one will be bigger?
G of x.
Yeah.
Right, makes sense. So the symbol stays. Okay, last one, and I promise this is the last one. What if I know or I see that the function is between 2 numbers? What does this mean? Same thing, same idea. Let's do that. So let's say this is m. Let's say this is m. And let's say this is the function on the interval a comma b. Maybe I should have presented, it will be easier to, let me present an m that is positive. Much better. So we can get the answer quickly. So what do you think? And what I'm asking basically is this. What do you think the area from m dx from a to b, and the area from a to b from f of x dx, and the area m dx from a to b? What is the relationship between, if I have this relationship between the function and 2 numbers, what will be the relationship between areas? I know it's silly because it's the same thing, and the integrals have to be in the same order. Okay. Oh, I forgot what there is still one more. Sorry, last one. Sorry. So let's take a look at this. Here's f of x, and here is a, b, c. What do you think of the area between a and b from f of x dx plus the area a to b from, let me write it again because there is no room there. And I will erase that. So what I wanted you to realize is that the integral from a to b plus the integral from b to c is the same with the integral from a to c. F of x dx, f of x dx, f of x dx. So this piece, which is this area, plus this piece, which is this area, is the same with the area from a to c, and vice versa. I can split the integral into two pieces or more. Or if I add two pieces, but remember, this has to be the same with this. No gap. So the integral from a to b plus the integral from b to c is the same with the integral from a to c from f of x dx. Any questions? I would like to apply these properties. And they are, yes, in 5.2.